Alright there everyone, welcome to our second tutorial in this series. Um, and today we're going to be going over the XOR gate. I decided to do XOR in an entirely separate tutorial because, well, I figure it's fairly different from NAND and NOR and basically NXOR but in reverse, but you get the idea. I feel like it's an entirely different concept that we need to go over. And now we can go over it using the gates that we learned last time. So, what this is going to look like is we're going to have two inputs, right? Just like AND or all those. So we have our two inputs, and they're connected up to a NOT gate. And by the way, what we're doing is we're trying to make an OR gate that instead of just returning if any of the values are true, including both of them together, we're trying to make it so that if either of the values are true, it returns true, but if both of them are true, it returns false. So the way that we do that is we have our NOT gates, let's name these A and B, and then we also have over here these wires going in these ways, and then we have our AND gates, and we're going to go ahead and plug both of those in, and then from here our AND gates are going to flow into an OR gate. And we can write this a little bit easier by going, hold on, we can actually write XOR, I believe it's by doing this is XOR as well. That's just itself on its own as like its own separate symbol. But anyways, now that we've seen this, let's go over how it actually works. Because this series is about logic as much as it is about computing. So if current is passed through only A but not B, it's going to go here through this NOT, and it's going to cancel here. It's going to go through this wire, and then this NOT gate means that we have current going here as well, meaning that we have current going through the AND, current going through the OR. That's all well and good. Same goes for the reverse because this is a very symmetrical circuit. But, oh yeah, obviously if neither are true, it's not going to activate the OR because that's pretty obvious. If neither input are true, then OR just doesn't go. But let's have a quick look at if, God, my fingers are going to be absolutely covered in ink after this. But let's have a look if at them both are true. A is going to go here and be blocked by the NOT gate, and so is B, meaning that the only two wires that are activated are this one and this one, meaning that the AND gates do not activate, and neither does our OR gate, meaning that we have basically created a gate that can function as a not and as well as an or at the same time. Kind of a weird way of explaining it, but um, anyway, rather short tutorial, but we're going to get back into everything with not and not or and all that later. So, goodbye.